Interactive Web, AI-driven code generation simplifying web development for novices by Zhang, Vyom, Kumar, and Max.
Oh, so-
All right, so this is our table of contents. Yeah.
So, speaking from personal experience, about a year ago, I started feeling extremely burnt out from coding, and I felt that I could no longer find ways to work out on my ideas. So during that time, I started experimenting with ChatGPT, and I wondered, what if I could just see the code that ChatGPT generated immediately? After some more time, our project has gotten a lot more features than we initially thought, and is shown to be useful in many scenarios. So we think that it can truly have an impact in all types of web development, whether you want to spend less time on mundane coding aspects or create a game.
Before moving on to more about our project, here are some statistics regarding our topic. Studies indicate that 83% programmers experience burnout due to unclear goals, insufficient processes, and high workload. Additionally, prolonged engagement can negatively impact programmers, leading to disrupted sleep, depression, stress, sensory overload, reduced social interactions, and even suicidal thoughts.
Okay, so what actually is interactive web? Well, interactive web is a platform that simplifies web and game development by combining real-time user interaction, AI-powered automation, and iterative development. So basically, it enables developers to see immediate updates to their projects while AI handles mundane tasks like debugging and refining code. This will allow developers to focus on more creative aspects of the game, such as design and gameplay mechanics rather than repetitive coding. Unlike traditional workflows, interactive web reduces barriers for novice developers, making accessible for those with little coding experience. And with features like a built-in testing window, the platform enhances productivity and creativity. And by automating tedious processes, Interactive Web addresses the core challenges of high workloads and insufficient coding processes, enabling developers to work more efficiently.
So some questions that you may be thinking about regarding our program could be, how can an AI like ChatGPT generate accurate, functioning code without hallucinations or deviations from the original prompt? To that, we would probably respond, the latest GPT-4 model, particularly when fine-tuned for code generation, has significantly improved in understanding and maintaining alignment with complex programming prompts. This model can process context more effectively and produce coherent, logically consistent code. Additionally, we integrated mechanisms within InteractiveWeb that verify the code in stages, catching any discrepancies early in development process. This approach allows for higher accuracy in generating code. Another question would be, there are so many people who can program in this world. Why do we need this program? Programming inherently takes a lot of time to learn, with many students studying for many years to create basic programs. This program is a precursor for many other programs, which will allow for people with zero programming experience to code something using just their native language, such as English, Spanish, whatever language you want. And lastly, why can't we just copy paste from ChatGPT? Our program is, like, granted, similar to copy pasting from ChatGPT. However, our program has a few key benefits. It automatically flags errors, has a already provided game window that is built in, and it has a much faster work interface. There are so many other features that we've implemented that would bring our program a step above just copy pasting from ChatGPT that we will show later in the demo.
So Interactive Web is a website basically, and we use JSON for storing the data. And on the page, there are three text boxes that are HTML code, CSS, JavaScript, which the user can download or just copy. And if you type in a title which has no current game, InteractiveWeb will see that and create a small project, including the basic features ChatGPT thinks that game will require. If it does exist, there's buttons on screen where the user can update the current game, which will send the current code to ChatGPT along with suggestions, errors that are flagged automatically, and the suggestions are where you can type in current errors you see with the project and it will just ChatGPT will just notice and fix it in the next update. When it's completed, it's sent to JSON for storing and the page is reloaded to immediately show the new version. And lastly, if the new version or update is below satisfactory, there's also a revert button that allows the user to return to the previous version again.
So building on what Max said, this slide highlights what actually happens when we run our game. By using the GPT 4.0 model through OpenAI's API, users can generate complete HTML, CSS, and JavaScript code in approximately 2 minutes. This ensures that even complex foundational elements are created quickly and effectively. Our platform leverages prior versions of code and user input to progressively refine and adapt outputs. This iterative approach ensures each version aligns closely with user expectations, reducing the need for manual corrections. To achieve this, integrated several key technologies such as jQuery, Express.js, Firebase, and other foundational tools like Ajax, TypeScript, and of course, OpenAI's API. Together, these components streamline the development process, making InteractiveWeb both robust and user-friendly.
So here's our chart on how our program works. As you can see, the game generates code from ChatGPT to create an initial version of the game. Then after that, it will display the newly generated code that is stored on JSON using the JavaScript Express library. And displayed with the generated code, there are also buttons on the website, which we'll see later, that can send feedback to the ChatGPT for the next update, as well as an update button. So everything is accessible on the front end. So and they can also be these can be used to generate new instances of code which are stored back inside the JSON, which are also displayed again.
Example creations. Here and the next slide will be some examples of games I created. On the left, the screenshot of a rotating 3D WebGL where you could spawn squares by pressing a key, and each square had a different side and rotated. On the right was the classic 2048 game, and InteractiveWeb did surprisingly well for this and created this that looked very similar to the actual game.
This slide also showcases another one of our standout creations from InteractiveWeb. On the right, it's a fully functional chess game, and on the left is a fully functional chat room. So ChatGPT generated all the core logic for the chess game, including like piece movement rules, turn management, and win conditions. And on the left, the chat room demonstrates how InteractiveWeb can handle both game mechanics and other auxiliary features like multiplayer functionality. This project highlights the platform's ability to not only simplify coding, but also deliver dynamic interactive applications that engage users.
So here's the data collected from making some of our games. So as seen, the cost of the update doesn't amount to much. It usually stays below 3 cents, and all the features end up working in the end. However, there are times where the features don't work as intended. And typically when this happens, there's a bug in the program created by ChatGPT, and that bug would be reported and uh to sent to the JSON automatically, where on the next update, ChatGPT can access that bug and try to fix it. Otherwise, throughout the experiment, all of these the first three columns all don't fluctuate and they increase in a linear rate.
Here's another experimental data chart. So as the number of comments or suggestions you add in, the time taken generally increases like linearly. Updates with one comment usually take 12.5 to 18.5 seconds, while updates with four comments peak at 40 seconds. That was kind of shown in the last slide too. And we noticed a slight variation in time for updates with the same number of comments, suggesting that like having the same comments isn't the sole reason, and complexity probably also impacts it. And the system demonstrates how the consistent scaling with increased input, suggesting its capability to handle more complex updates without excessive delay.
Okay, so here's another chart. This chart highlights the relationship between the number of comments in an update and the associated costs. So as you can see, the cost scale predictably, starting at around 1 cent for like one comment and reaching a maximum of 3 cents for updates with four comments. This linear increases ensures financial predictability and scalability without unexpected spikes. Each additional comment adds approximately 1 cent, making budgeting straightforward for developers. Lightweight updates remain highly cost-effective, while even the most complex updates are affordable, demonstrating the platform's efficiency and suitability for real-time and iterative development.
So here's our fourth experiment. As you can see, here's the graph showing the cost of the update versus the time taken. And we can almost see a linear correlation here through the graph, although with a multitude of outliers in the 2 cent range. Outside of that, there are lots of clusters of data points, and those show the reliability of the speed of the system. So overall, the cost and time taken both rise as the amount of text that the ChatGPT has to handle rises as well.
Challenges and solutions. Some challenges we faced were that the AI token limits. Since GPT models have a set amount of token limits that restrict the complexity of any generated code. However, we try to combat this by fine-tuning our prompt and making it as efficient and concise as possible to ensure that the least amount of tokens are used. Number two, scalability on other languages. Currently, this is only for web development and games using HTML, JavaScript, CSS. But it's easy to like move our program to different languages, for example, Python and Java. Usage. Where do users get the generated code for personal usage? It seems like it just puts the game window and you can't really do much with it. Answer, we added in text areas that unstringify the JSON and have sections for the JS, CSS, HTML, and multiplayer section for personal use. And if you want, you can download it as a zip option for easy usage.
Okay, so our first comparative analysis is with Ludo AI. Ludo AI is a platform that allows game developers to design and create games by helping them create ideas, track market trends, and provide them with researching tools. It helps them to boost their ideation process, organize assets, and make it easier to create games that align with current trends. Moreover, Ludo AI gives users tools to create new assets, mechanics, and more engaging and market-ready games. It also allows for teams to work together and transfer ideas. However, Ludo AI focuses more on the ideation process, which only accounts for about 29% in a combination with other factors of burnout for developers under unclear goals and targets. The rest, high workload and inefficient process, account for a total of 47% and 31% respectively, as the causes of burnout. Is what our project hopes to subside. By fixing the bigger problem created by coding, our project is more effective than Ludo AI by a substantial margin because our project handles the much larger problem of high workload and inefficient processes and lets the programmer find the ideas by themselves.
Our next comparative analysis is with Giz.ai. Giz.ai takes inspiration from pre-made prompts and uses them to generate games. It uses AI to generate a storyline, sounds, and pictures that represent the time. The concept seems cool, but it doesn't generate an actual game with real player interaction, only a text-based RPG, which isn't generated from code. Unlike Giz.ai, our project generates a real playable game that is fun to create. The process of converting ideas into code creates a wider range of experiences, unlike Giz.ai's purely storytelling perspective. The availability of an infinite possible amount of prompts from a user destroys a limited scale prompt that only results in AI-generated images, sounds, and text. Overall, our program simply has a lot more useful features.
Lastly, our third comparative analysis is Workit. Workit AI code generator functions similarly to ChatGPT for generating code, and it's compatible with most programming languages. It was designed to assist users working alongside other IDEs, but lacks its own integrated development environment. Some limitations include that there's no capability to debug its personal code. It's basically similar to ChatGPT, but offers no significant advantage, and often the results produced are the same or slightly worse than ChatGPT. As for our program, provides the automated debugging, as we said before, and includes features to already display the part of the work to adding transparency and troubleshooting, and uses advanced prompt engineering to generate more refined and reliable results as once the project becomes more and more complex, using past versions and our prompt will make sure the result is always usable or revertible. This effectively addresses the common issue of bugs in ChatGPT generated code, providing a more user-friendly experience than WorkGig AI.
While InteractiveWeb has achieved quite a lot, there are still many areas for improvement. For example, our multiplayer feature is currently in its very experimental phase and requires further refinement to ensure its stability and usability. Additionally, ChatGPT sometimes produces hallucinations, generating inaccurate code. So we aim to integrate more reliable models to enhance output quality. We're also working on optimizing the update process by skipping unchanged sections of the code, reducing time and costs for iterative development. These improvements will make the platform even more efficient and robust, ensuring it continues to meet the needs of the developers. All right, so now we're gonna show you a live demo and conclude with our final goal.
We'll show the live demo first. Can you guys see my screen? Can you guys see my screen?
Yeah.
Okay.
Yeah.
So one of the first features I like to show off is the our login feature. So we used Firebase to add like a login menu, which also and the emails are also used in and stored inside some of these games. So for example, if we go to let's see, if we go to like 2048, this game isn't a multiplayer game, but it's a game that was generated by ChatGPT. So as you can see, it's just like the normal game. Here's all the code for it that we had. It's all generated by ChatGPT. Back. So next, so this is another game. This one actually does have multiplayer features, so I'm going to actually access this from a different website just to show you the features.
Wait, Kai, I can like put blocks too, if you want.
Okay, that's good. So for example, if I put this block here, you can see I put that on my other computer. I did nothing on this computer. I'm gonna keep my cursor up here. I'm gonna place
Wait,
another one.
I'm gonna put a 3x1 here.
Okay.
Yeah.
So you can just drag things around. So as you can see there, that was actually a bug. So that was a 2x3 piece that placed as this. So now what we can do is we can write down something like um so this you can send the comment directly to ChatGPT. This isn't I need to log back in because this isn't an admin account within Firebase. So as you can see, I just logged in with a different account, and this actually has
Wait,
all the
you
admin
can show
information.
them the JSON, right? With the
Sure.
comment.
Yeah.
So I can send the update button here. So here's the, what's actually happening behind the scenes when we're placing the blocks. So ChatGPT is sending this through something, and here's actually the error that I just put in. So it puts this automatically in ChatGPT, which is being updated right now, as you can see here. So we're gonna wait on this website until this update happens. Until we can. See, earlier that the code just right after an update is finished, the game reloads itself using the express.js features. So now ideally in this version, the blocks won't be weird. Sorry. I'll use the
Okay, I think it worked for me.
okay.
All right.
So that was our demo.
Oh, also show them like how you can download it as a zip. Kinda like-
Okay, so another thing you can do, like this would probably only work for the non-multiplayer games. What you can do is you can download the zip file, and this feature isn't like fully working, I guess, but you can open the, for example, you can open this, but I think there's something wrong with this code. Let me check if it's
Wait, maybe you
yes,
can like
this
create a
game's a
new game.
multiplayer game. Because this game's a
Oh,
multiplayer game, then it won't work for the download zip. Okay.
Maybe you can demo like creating a simple new game, like some random clicker game. I don't know. Or do we
yeah.
have that? Or just
Uh,
like do a random.
this one should work. I mean, doesn't actually have any code in it. So I guess we'll do another update. So for this, we'll actually show what's happening behind the scenes. So the update already finished though. So what's happening is that it's sending it to one of these JSON files, and I think it just went to it goes to the file that's named called clicker.
Wait, I think I just put the homepage code in here for some, just,
Oh,
it just
okay.
updated the whatever.
Yeah.
Yeah, just updated the
In that
homepage.
case, thank you guys for listening, and this was our presentation for